Okay, so good afternoon to all IEM and UEM family members again. Today we are at a different time, 45 minutes behind. The reason is that has started in IEM Kolkata, and as we all know, the exams are supposed to continue till 4:30, 4:35, sometimes up to 4:40. So we will start it at 4:45 going forward for this month at least. So today the presentation will be done by Professor Sumit Paul from the Department of Mechanical Engineering at the University of Engineering and Management, Jaipur. So his topic is technology behind essential appurtenances in our everyday life. Okay, that's an interesting topic. Everything that is needed in our life. What is the technology behind that? A very, very broad topic to be talking about, I believe. But yes, I believe also that Professor Sumit, you will make it easy for everybody to understand. So you may kindly take over from here. And one excuse to all of you I will be giving today, I have got another session at 5:30, not 5:30, rather just 5 minutes prior to that I will have to start. So you can understand I will have to leave by 5:15. So I request Professor Sumit, if you can kindly complete it by 5:12, 5:13 max to max, so that we can take the question answer at least for 2 to 3 minutes. Okay. So you may
Okay,
kindly
sir.
take over from here. Thank you.
Okay, sir. Thank you, sir. Good afternoon, everyone present in this webinar. First of all, I like to thank our respected Chancellor, sir, Vice Chancellor, sir, Provost, sir, and Dean, sir, for giving me this opportunity to talk in front of you. And thank you, all my dear colleagues. My topic is technology behind essential appurtenance in our everyday life. Actually, in our daily life, we are using various tactile or non-tactile things like electricity, air conditioning system, and automobile for transportation, which are very essential for our living. We cannot imagine a single day without help of these things. And among all, this electricity is playing a most essential role. And in the summer, air conditioning system also helping us a lot to survive. Another most important thing is automobile. Without this, we cannot go anywhere, whether for work or any place which is more than 3 to 4 kilometers apart from us. And often we don't know the technology behind the important uses. So when our dean sir told me that I have to present something in this afternoon meeting, the idea came into my mind, why not I should talk regarding these essential technologies which are helping us a lot. So this is my presentation overview. I will be talking regarding engine, how engines are helping us, different types of engine, IC engine, EC engine, and different types of IC engine also, reciprocating type and rotary type. Reciprocating type engines also runs on different types of fuel. So depending upon that, the working principle of reciprocating IC engine is also different. I will be discussing that. And after all, air conditioning system. So let's talk about engine. Heat engine have several useful importance in human life. Basically, engine is that which converts one form of energy into another. In the case of heat engine, the chemical energy of fuel is used to generate heat energy, and that heat energy converted into mechanical work output by some arrangement. Now, by utilizing that work, we can generate electricity or we can run vehicle. If we attach any alternator with the engine, that combination will produce electricity. And if we attach propeller with engine shaft, that can run marine ships. If we attach wheel, that can run a vehicle, a automobile. Like this, there are various operational benefits of IC engine or engines. Now, heat engines have types based on burning process. One is internal combustion engine, another is external combustion engine. Now, what is internal combustion and what is external combustion? By the name, we can easily depict that internal combustion engine is that type of engine where the burning or combustion takes place inside a closed chamber. And in the case of external combustion engine or AC engine, fuel will be burned outside the engine, and the heat energy which will be produced due to this burning will be utilized to run the engine. Now, for example, we can take steam engine or steam turbine. The heat generated due to the combustion of fuel is employed to generate high pressure steam, which is used as working fluid in a reciprocating engine or in a turbine. In the case of spark ignition engine or SI engine, which generally petrol or gasoline or diesel is used as fuel, the product of combustion generated by the combustion process of fuel and air within the cylinder form the working fluid. Now, even though reciprocating IC engines looks quite simple, they're highly complex machines. There are hundreds of components which have to perform their functions congruently to produce power output. There are two types of IC engines. One is spark ignition or SI engine, another is compression ignition or CI engine. So before understand the working principle, let let us go through some of the important engine components and nomenclature associated with this engine. So first of all, IC engine. You can see in this diagram, in this schematic diagram, every engine component is noted. There would be a cylinder block. Within that block, there would be a cylinder and piston arrangement. The piston can move to and fro within the cylinder. On the top of the cylinder block, there would be a head. Within that head, there would be a inlet manifold and the exhaust manifold. Through the inlet manifold, air or air fuel mixture will be taken inside the cylinder, and through the exhaust manifold, it will be expelled at the outside to the atmosphere. Now, there will be valves, inlet valve and exhaust valve, which will be operated by the cam operation, and it will be open and closed depending upon the working. And there will be a spark plug which will be located centrally for spark ignition engine. And instead of spark plug, there will be some injector or the injector to spray the fuel inside the combustion chamber in compression ignition engine. Now, piston will be connected through a connecting rod with a crankshaft, and the connecting rod will be attached with the piston by a Gaussian pin on piston pin. This piston can move between two dead center. One is top dead center, another is bottom dead center for vertical engine, and it will be called inner dead center and outer dead center for horizontal engine. So beyond these two limit, piston cannot move. So above the top dead center, there would be some volume provided which will be used to keep the gas after compression. Now, one movement between top dead center to bottom dead center of the piston or bottom dead center to top dead center is called stroke. Now let's understand the working principle of four-stroke petrol engine or four-stroke spark ignition engine. The principle of operation of the spark ignition engine was invented by Nicholas A. Otto in the year 1876. Hence, SI engine is also called the Otto engine, and the thermodynamic cycle on which it works is called Otto cycle. So can you imagine that how beautifully he have designed a machine, how beautifully he have developed a technology which is still irreplaceable? Maybe we will be using this technology more than 2-3 decades until the other form of technology which can develop mechanical work become ubiquitous and until fossil fuels become extinct. There are also two-stroke engines, but I'll be discussing the working principle of four-stroke engine. Why? Because two-stroke engine have much more waste. There will be much more fuel waste in two-stroke engine, which is very hazardous to the environment. So that's why these two-stroke engines become obsolete. So let's understand the working principle of SI engine.
Professor Sumit,
Consider,
Professor Sumit,
yes, sir.
can I just disturb you? Sorry, once. See, I believe
Yes,
Professor Dr. Pradeep Sharma has joined this, and he can take over my position if the question answer session needs to be addressed. So I believe you need not hurry. You can go through your presentation normally. I believe so. Professor
okay,
Sharma, are you there? Professor Sharma, are you there?
Yes, sir. Yes, sir. Yes, sir.
Okay, so he can take the question answer session, so no worries. You don't need to hurry through your slides and complete it by 5:15, as I was saying. You may go at your
okay,
normal speed. Okay, thank you. Sorry for
okay,
sorry
sir.
for the disturbance. Okay,
Okay, sir, can I continue?
can you please?
Yes, 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 please.
Okay, so let's understand the working principle of petrol engine or spark ignition engine, which runs on four-stroke cycle. Consider, first of all, the piston is at top dead center. Piston is at the topmost dead center, and the inlet valve is completely open. Now, will be arrangement of self-starter, which is generally a motor, and it will rotate the flywheel which will be attached to this crankshaft. Then crankshaft will rotate. So eventually this crankshaft will push the piston in downward direction. Now, as the piston going towards downward direction, this cylinder is now connected to this inlet port to the atmosphere because valve is open, inlet valve is open, and there will be some creation of vacuum. Now the question is, what is vacuum and how does it creates? See, whenever there will be a downward movement of the piston, there would be a increase of volume inside the combustion chamber. Now, as we know, if we increase the volume, the gas expanded and eventually the pressure drops. Now, any pressure which is below atmospheric pressure is called vacuum pressure. That may be also called negative pressure sometimes. So now the gas was initially at atmospheric pressure. Now, due to this downward movement of the piston, the pressure dropped down below the atmospheric pressure, so the vacuum is created. So eventually, this vacuum will not be stationary. This vacuum will be filled up by introducing fresh charge or fresh air fuel mixture from the outside. That air fuel mixture will be produced in a carburetor by a carburation process. That is a separate process. Then gradually this piston go towards the downward center, and the cylinder volume will be filled up by the fresh air fuel mixture. Now, as soon as the piston reaches the bottom dead center, this inlet valve will be closed by cam operation. So this movement from top dead center to bottom dead center is completing one stroke. That stroke will be called intake or suction stroke. It is sucking the air from the outside, air fuel mixture from the outside. That's why suction stroke. Now, for the next stroke, see, this crank is continuously rotating. By self-starter, it is rotating. So again, the piston will try to move towards top dead center. Now, during this movement, these both of the valve is closed. In every direction it is closed, and piston will push the gas. Now, due to this pushing, the pressure and temperature will increase. So compression will occur. This is called compression stroke. This compression stroke will happen during the movement of piston from bottom dead center to top dead center. So all the gas will compressed and situated in the clearance volume. Now in the next stroke, the piston will again move towards bottom dead center from the top dead center. Now we need to burn the fuel. During this movement, actually we need to generate the power. So that's why a spark plug will be provided, which will generate some sparks, and that will ignite the fuel and burn all the fuel. So after the burning, there will be generation of tremendous pressure. Now that pressure will be utilized by this engine, and it will push the piston furthermore in downward direction, and we will get some work output. After end of this stroke, we will open the exhaust valve and next stroke will occur. As soon as we will open the engine will open the exhaust valve, the remaining pressure will be expelled outside at the atmosphere. Now still there will be some pressure against which the piston need to be work, and piston need to be push all the remaining burned gas at the atmosphere. So in the next stroke, the piston will move from bottom dead center to top dead center again, and it will wash out all the burned gas at the atmosphere, so that the engine can take fresh air fuel mixture again for the next cycle. Like this, if we run these 4 strokes 2-3 times, our engine will be in the operating condition. And by happening this stroke consecutively again and again, by this cycle again and again, we can generate work output continuously. So this is basic working principle of petrol engine. Now let's talk about diesel engine. In this diagram, in this schematic diagram, you can see the engine components are more or less same for diesel engine also and SI engine also. Only difference is there the fuel injector. The fuel injector will be there in diesel engine instead of a spark plug, and there may be a glow plug which will aid the starting. There is no other difference. Same intake valve, exhaust valve, piston, connecting rod, cylinder, crankshaft, everything will be same. I'm not going into that details. Let's come to the straight of working principle of diesel engine. In the same way, diesel engine also comprise 4 stroke. First of all, intake or suction, then compression, then combustion or power, and then exhaust. So like petrol engine also, consider the piston is at top dead center now, and inlet valve is open. Now, due to cranking, due to self-start, the piston will move towards bottom dead center, vacuum will be created, and that vacuum will be filled up by fresh air, only fresh air in this case, by introduction of fresh air from the atmosphere. Now, during this movement from top dead center to bottom dead center, the cylinder will be filled up by the fresh air. And end of the stroke, the engine will operate the cam and close the inlet valve. Now again, piston will move towards top dead center. Now during this movement, all the valves are closed. In every direction it is closed. Piston is moving towards top dead center. So it will compress the gas. Now after compression, the pressure and temperature will increase. Then in the next stroke, at the beginning of this stroke, the engine will start the fuel injecting process by a injector. Injector will spray the fuel inside the combustion chamber in atomized way. The atomization is required because it will increase the surface area of the fuel so that the fuel can easily vaporize and mixed up thoroughly with the air, and that air fuel mixture will get burned easily so that there will be no unburned fuel. Now this burning will take place by itself due to low self-ignition temperature of diesel. See, diesel have relatively low self-ignition temperature than petrol. That's why it will get spun itself. Whatever temperature has been achieved due to compression, at the end of compression, that temperature will be sufficient to burn the fuel. Now for the petrol engine, the petrol have much more self-ignition temperature than diesel. So after compression also, the self-ignition temperature of the petrol cannot be achieved. So that's why a spark plug is required. Now in the case of diesel engine, no spark plug will be required because due to low self-ignition temperature, and after compression the temperature is that much that will be sufficient to burn that fuel. So it will ignite and eventually all the air fuel mixture will be gets burned. Now due to this burning, there will be release of heat. That heat will increase the pressure furthermore. So there will be generation of tremendous pressure inside the combustion chamber. Now due to this huge pressure, it will push the piston in downward direction. So piston will now move towards bottom dead center and we will get power output. Now in the next stroke, as the piston reaches bottom dead center, the engine will open the exhaust valve. As soon as the engine will open the exhaust valve, all the pressure will try to expel at the atmosphere. Even though due to the smaller opening of exhaust port, all the pressure cannot be expelled. Now the piston have to work against that pressure and it need to wash out all the burnt product at the atmosphere. So we can see in this three-stroke intake, compression and exhaust for both the SI and CI engine, it is taking some power, and during this power stroke it is developing some power. Now that power will be stored in a flywheel, and during this intake, compression, exhaust stroke it will be delivered. And by happening this cycle one after another, we can get continuous power output from the engine. So for the starting 2-3 times we need to rotate the crank, then the engine will start and will work continuously. So this is the basic working principle of diesel engine or diesel cycle. My next topic of discussion is rotary type IC engine. Till now we have discussed reciprocating type IC engine, reciprocating type internal combustion engine. Now I will be discussing rotary type internal combustion. Rotary type of internal combustion engine basically run on Brayton cycle. That may be open loop, that may be closed loop. The Brayton cycle is called, this type of cycle is called gas turbine actually. In the gas turbine, there would be a compressor, there would be a turbine, and there would be a combustion chamber. In open loop system, fresh air will be taken from the atmosphere. And by the compressor, you can see the compressor is converging type. It will compress the fresh air which will be taken from the atmosphere, and after compression, it will send that into a combustion chamber where fuel and air will be added to burn for the burning process. So after compression, there will be increase of pressure up to some extent. Now, after burning or inside the combustion chamber, there will be increase of pressure furthermore. Now that pressure will be utilized by a turbine. The turbine will expand that, and upon expansion, the air which is at tremendous pressure will rotate the turbine blades, and eventually it will rotate the turbine shaft, and we can get rotary form of work output directly. One example of Brayton cycle, open loop Brayton cycle, is aeroplane engine, aeroplane gas turbine, where you can see in this diagram a compressor will be there in the first part that will compress the air and send into this combustion chamber, where some burners will be provided. That burner will spray the fuel with the gasoline inside the combustion chamber, and it will ignite, and it will release heat energy. That heat energy will be transferred to the air, and it will increase the pressure and temperature of the air furthermore. Now that huge pressure will be utilized by this turbine. It will expand it to this turbine, and it will rotate the turbine blades, and that will be connected to the turbine shaft. It will rotate the turbine shaft. In the Brayton cycle, the turbine and compressor is typically mounted on the same shaft so that the compression can take work, what part of work, whatever turbine is developing, and we will get a net work output. And in closed loop system, the same air will be flowing again and again for each and every cycle. In open loop system, after expansion, the air will be expelled, air will be exhausted at the atmosphere again. But in closed loop system, the same air will be rotated in the cycle again and again. After expansion in turbine, it will be go through a heat exchanger where heat will be taken out, and it will again send to the compressor for compression process. Example of closed loop Brayton cycle or closed loop gas turbine is generally used to generate power, electrical power. Now let's discuss about EC engine. The typical example of external combustion engine is thermal power plant. Thermal power plants runs on Rankine cycle, based on Rankine cycle. In the Rankine cycle, there will be a boiler. In the boiler, fuel will be sent, and actually the pulverized coal will be sent as a fuel, and to burn that fuel we need to introduce air, because the necessary oxygen for the burning will be taken from the air, and the fuel gets burned. Now due to burning, the fuel will release huge amount of heat energy. That heat energy will be utilized to generate steam from water, and the steam will be so much heated that it will be under superheated stage. Now after burning, the product of burning of fuel of air mixture that will be sent to a stack after series of operation uh, which will be done, because this if we expel this fuel burn product, that will be very much hazardous to environment. So some operation will be done so that it cannot affect, so that it cannot show any detrimental effect to the environment. Now in the boiler, superheated steam has been produced. Now superheated steam will be sent to a turbine again. That steam is at huge pressure and temperature. Now this turbine, the steam turbine basically will expand that steam, and it will rotate the turbine blades upon expansion and rotate the turbine shaft, and we will get rotary form of work output. Now there will be a electric generator or alternator will be attached with the turbine shaft, which will generate electricity, and it will supply to our home. Now after expansion by the turbine, the water is still in gaseous state or semi-liquid state, the combination of gaseous and semi-liquid state. Now that need to be pumped up again into the boiler. Now this semi-liquid and gaseous state can be pumped up with the use of a compressor, but that would be very tenacious process. It will be very costly, and it will be it will take much more effort. That's why engineers come to the solution that why not condense it, and the semi-liquid and gaseous state uh, comes into completely liquid state, so that by only using a centrifugal feed water pump, we can feed it again into the boiler and create sufficient pressure which is needed in the boiler. So a condensation will be there, where the heat will be taken out, further heat will be taken out by the condensation process. In that process, actually, a separate pump will continuously circulate cold water into the heat exchanger, and that steam, semi-liquid and gaseous steam, will be desiccate heat into that cold water, and it will be comes into completely liquid state. So a cooling tower is needed if the plant is far from the river. If the plant is nearer to river water used for this cooling process. Now needs liquid water again will be pumped up into the boiler by a feed water pump. This will be basically centrifugal type, and necessary pressure will be developed. And again this cycle will rotate. Like this, we can generate electricity. Now, why I have discussed the Rankine cycle or thermal power plant? Because most of the electricity, nearer to 60%, is generated by the thermal power plant. Other form of energy is there, which is 40%. There may be hydroelectric plant, there may be renewable energy, there may be nuclear energy also. Now let's understand working principle of air conditioning system. Many of us may think that our room AC cooling atmospheric air outside air and sending it to inside our room, but it is actually not happening. There is a cycle in which a refrigerant circulate. There will be two units in our split AC or room AC. One is inside room, another is outside room. In the inside room unit, there will be a evaporator which will evaporate the refrigerant, and upon evaporation, the refrigerant cool down and it will take heat from our room, and after that it will be compressed by a compressor, and due to compression the gas or refrigerant condense and that reject heat at the outside of the room. Like this it's work. Let's understand that properly. First of all, suppose we are starting from the compressor. Compressor is compressing the refrigerant. So initially it was at gaseous state. It is now compressed by the compressor and becomes liquid state. That liquid state now rotate through a coil, through a heat exchanger. Now during this, the refrigerant rejects heat at the atmosphere. Now a fan is there to circulate atmospheric air to cool down it furthermore. So refrigerant now getting cooled in the condenser. Now that fluid, that liquid state refrigerant now will be sent to a expansion valve. What does expansion valve do? Expansion valve expand the liquid state refrigerant, and upon expansion the volume will increase and the gas will cool down. Now if we rotate that in a coil or in a heat exchanger, and if we flow some air into that, that air will be cooled down. So in our inside unit, the refrigerant of gaseous state will be sent after expansion, and that will be very cold, and our room air will be circulated through that heat exchanger, so that the heat from the room air can be taken inside the refrigerator, taken inside the refrigerant or the fluid we are using in the AC or in the gas. And like this, the room heat will be taken inside the refrigerant or gas of the AC, and it will be again sent in the compressor. Compressor again it will compress the gas, and the gas will becomes in liquid state. That liquid now again reject heat in the outside unit. Like this, again and again, our same refrigerant, same gas rotate in a cycle, and thus our room can be get cold. Now there would be a sensing unit which will be sensing the room temperature depending upon our need, and it will stop the cycle once the our uh, desirable temperature is achieved. So thank you all to keep patience to hear me. This is the end of my presentation. I hope you have understood little bit regarding this working principle of daily appurtenance. Thank you, sir.
So, Professor Sumit, it was nice presentation. So should I post the poll now?
Yes, sir.
Okay, the poll is like between the following technologies, which one do you find most interesting? This one?
Yes, yes.
So I will request all faculty members, all the participants over here to vote for the polls. Already we have reached 42-43%. We have reached 45 seconds now, waiting for votes to reach at least 50-55%. Okay, we have reached 51%. So I'm just sharing the result. Professor Sumit, I think you are able to see the result. The question was, between the following technologies, which one do you find most interesting? IC engine got 48%, gas turbine got 9%, thermal power plant got 16%, and air conditioning 27%. What is your view on this?
Yes, sir. IC engine have much more interesting parts, but
Okay.
every engineering is beautiful and interesting, I think.
Okay. So I'm hiding now this and going to the questions. Let us see. So there are few comments for the presentation from Sanjay Mandal. Nice presentation. Okay, but there are no questions. So I will request, if anybody wants to ask something, kindly write the question in the question box, the chat box also. Madhusudan Badya has given one good comment for you, a good presentation.
Thank you, sir.
So I'm unable to find any question right now. So I am again requesting, if anybody wants to ask something related to the present topic, he or she may ask, writing the question in the question panel. Okay, so I'm not getting any question, Professor Sumit. Thank you. It was a nice presentation. Thanks
Thank
to
you, sir.
all IEM UEM members. Thank you. Thanks a lot.
Thank you, sir. Have a good
Thank
day.
you.